Good evening, everyone. I guess this counts as a look inside video because I bought this flashlight at the dollar store. And, well, what I intended to do, as I open this up on the front, was to try to get the board out to possibly play with some other LEDs on it. But that didn't, there's a pressed in piece of metal that holds the board in place. Let's see, is that visible? I'll turn it to the light. You can see there's sort of like a pressed ring around the edge. And I can't really, I mean, it might be possible to unscrew it, but I don't have anything that will fit into those little grooves sufficiently well to attempt to get it out. I may try again, but for the moment I was stymied with that. But, you know, it's not that bad a little thing. There are no gaskets or anything on it, so it's not waterproof in any way. And inside it's got a little holder which holds 3 AAA batteries. And I guess it should be working. Ah, there it is. I didn't realize it had batteries in it though. And so, you know, perfectly usable little light, right? Kind of thing I might give to my daughter to play with. It's spun aluminum. It's pretty nifty. If it had gaskets, it'd be quite all right, but it's going to leak around the switch anyway. But I started looking at this. Now, just as a reminder, I'll turn on the calculator here. 3 alkaline AA batteries, 1.5 volts each, times 3. That should give us 4.5 volts as the nominal voltage. It will drop when they're under load, of course. And you could replace the batteries with nickel metal hydride batteries, of which I, surprise, surprise, have some here. And so this little battery holder is actually kind of interesting because it's marked, you know, positive, positive, but it's marked negative on that side and positive on that side, I guess. Yeah, it's positive on this side, negative on that side, and you have to get it in the right way around for it to work. So if we do nickel metal hydrides in here, oh, there we go, works. Switch is a bit touchy, but that's all right. I'm sure the color is going all around on the phone. Okay, so that's fine, right? But then I looked at the size of this tube, and I looked at it, and I looked at it, and I thought, that sure looks like it would hold an 18650. So, naturally, I tried it. Now, just a reminder, so we looked at these are probably zinc batteries that it came with, zinc carbon batteries. That gives you 4.5 volts. The nickel metal hydrides are 1.2 volts nominally, although they'll be higher when they're freshly charged. So 1.2 times 3 equals, so 3.6 volts. And a nickel metal hydride like this is going to be 4.2 when totally charged and 3.6 volts, you know, as its usual running voltage, right? There's a chip in this one. This is, as you can see, these have a chip level, and these EBL ones are pretty okay. So you put it in, it shakes around a little bit, but it fits perfectly inside the tailstock of the flashlight. Spring is a bit too long, but, and boom, there we go. Works with an 18650. And this got me worried about how much current it was drawing. I was thinking, well, you know, the thing about an 18650 and this flashlight with a high capacity 18650 in it is now a pretty heavy thing by comparison to having just 3 of these in it. But that got me thinking, so how much current is it drawing? And I hooked up meters and got it all set up to try to figure it out. And I'll give you some of what I found. I found overall that with the 18650, and it was at 4.15 volts at the time, it was drawing 350 milliamps, and I can't remember how many LEDs, I could do it backwards, but that worked out to 25 milliamps per LED. That's, you know, that's okay, right? It would be a little higher at 4.5 volts, although the internal resistance of these batteries might limit it, because that's the thing, there's no resistor in here. I've looked, I can't find it. I can't find any evidence of it. I've taken this apart, no resistor. I've measured various spots on the board. If there's a resistor in here, I can't find it, I can't measure it. The only resistance I can tell is from that and from just the, you know, you can see how the aluminum is chewing up. There are little bits of aluminum flakes all over the table here from it. That's it. That's where the resistance is. And it doesn't need a lot to control the current in here. Looking back at my calculations, what did I think the resistance is? Yeah, I think the resistance is probably about 3 ohms in there. That's what it's got to be. So, but it's not coming from a resistor. It's mainly coming from this spring, I think. Maybe this spring on the back, although it's steel, but it's a pretty chunky piece. It's just throughout the whole thing, there's about 3 ohms of resistance. And I mean, that's fine, I guess, but you know, there's a lot of current in that, and it makes me a little nervous to run it through something with no current regulation in it at all. So I think I will probably continue to use this with AAA batteries, but it's interesting, and certainly, I mean, this was from Dollarama here in Toronto in Canada, but I'm sure the same thing is being sold by other stores. This is a potentially quite interesting thing to use for projects, assuming you could figure out how to unscrew that little metal piece in the thing. And I think it's, yeah, I'm sure it's just jammed in, because you can see the scratches on the sides when they press that in. Well, thanks for watching. I just thought this would be an interesting look inside a flashlight that I believe I paid $4 for at the dollar store, where a lot of things aren't $1 anymore. Have a good evening. Thanks.